Pre-calc honor students, here we go with 16.4, problem solved with combinations. Sometimes probability problems become so huge that it's virtually impossible to list the entire sample space. But we can count up the sample space with combinations quickly. So let's look at our first example. 5 cards are drawn at random from a standard deck. Find the probability that all 5 cards are hearts. Well, here's the conditional probability approach, and that is, it's just a very simple tree diagram because each card is a heart. The first card is a heart, is 13 out of 52. Now it's conditional because this first card being heart has changed the probability for the second card being heart. Now you only have 51 cards and only 12 of them are hearts. And then 11 out of 50, and then 10 out of 49, and then 9 out of 48. And we expand that all out, and we get 33 out of 66640. Let's just check that on our calculator. Make sure you got the right. Indeed, we are correct. We get 33 out of 66640, or 0.000495. Sometimes when probabilities are that small, we like to actually write them in this sort of man-in-the-street type of terminology, 1 in 2019. So that might mean something more to people, like it's less than 1 in a 2,000 chance of this happening. Now that's the first approach, conditional probability. This approach doesn't work so well, though, if we have types of problems where it might not be all the same thing. Let's take this approach on again with combinations. And that is, you're drawing 5 cards from a deck. So I usually like to start with the denominator, 52C5. Those are all the ways you can pull 5 cards out of a deck. And I believe that's 2,598,600, something like that. I'll check that. Well, we can check that right now with combinations, right? 52C5. Call up combinations under C. Combinations. Actually, it's under N, NCR. Yep. NCR 52, 5. 2,590,960. What was I thinking? Oh my gosh. Mine's going 960. Okay, 2.6 million ways you could draw 5 cards from a deck. Now, we want to now focus on how many ways could you find 5 cards that are hearts. Well, there's 13 hearts in the deck, and we want to choose 5 of those hearts. See how this is a little different? And when we do 13C5, and as long as you got your combinations out, you got that pretty quick there, right? 1287. 1287 out of 2,590,960. I would accept that as an answer. You can check on your calculator by actually dividing it out, and divide by that 2,598,960. And the calculator reduces it to it again to 33 out of 66640. Okay. Now I give you 2 approaches because now sometimes the first approach, conditional probability, is too unrealistic. Example 2, 5 cards are drawn. Here, let's make a little space here for example 2. 5 cards are drawn at random from a standard deck. Find the probability that exactly 2 are hearts. Now, this is where students make a lot of mistakes sometimes. They figure, okay, you're drawing out 5 cards again, so it's 52C5. And that's that 2,598,960. And you can see how it's going to be impossible to list all those and pick out the ones where you have exactly 2 hearts. And where some kids go wrong is they just do 13C2. Well, you have to remember that this is the sample space. That is 5 card hands that you're drawing from a deck. You're only pulling a 2 card hand here. So you have to fill the cards and say, and 3 non-hearts. You have to fill up your event space has to be a subset of the sample space, so it too must be a 5 card hand. So you have to multiply this by all the ways we get 3 non-hearts. Well, if there's 13 hearts, there's 39 non-hearts for the other 3 suits. Combination 3. So 13C2. $13C2 on your calculator works out to be 78. And 39C3 works out to be 9,139. When we multiply these two together, we get 712,842. And you could stop there and just give this as your answer, because I can actually inspect, did you get the right sample space and do you have the correct event space? I would do it on the calculator just to make sure it's making sense. This divided by your 2.6 million. And the calculator gives a fully reduced answer of 9,139 over 33320. And then if we do the diamond divide, we get the 0.274. Check the answer in the book there. Okay? All right, now let's try another one. Here we've got 13 cards dealt from a well-shuffled deck. What is the probability that 13 cards contain exactly 4 aces and exactly 3 kings? So again, watch out. 52C13, is that going to be more or less? What do you think? Than the 2.6 million poker hands. These are basically bridge hands now. Is it going to be more or less? Well, it's a lot more, of course, because you're heading toward the center of the combination. 52C26 is where it would peak. Those are basically war hands when you and a partner divide up all the cards. But now we want to contain 4 aces and 3 kings. Remember, and that means, and then you've only burned up 7 of the 13 cards. You have to have 6 non-ace, non-kings. So that's going to be 4 aces are 4C4. 3 kings, 4C3, and there's going to be 4 ways to do that. And we need to get 6 non-aces, non-kings. Well, you've got 52 cards. You've pulled out the aces and kings, so take out 8, and you're down to 44 cards. So 44C6. What's often the case here is your left subscripts add up to the total thing you're tapping from. 8 and 44 is 52. And the right subscripts add up to how many you're taking at a time? 4 and 3 and 6, 7, 6, 13. So what do we get here? We get 4C4, which is 1. 4C3, which is 4. 44C6, that's going to be higher. 44C6. That works out to be 7,059,052. All over 52C13, and that's going to be big. Wow. Let's just write down the digits here. 6, 350, 135, 596, 00. Whoa. 635 billion. Okay, now what am I going to accept for an exact answer on this? Well, I just multiply out the numerator 4 times. That's 705. And we get 28,236,208. Over the bottom, which is 635 billion, 13,559,600. You can stop at that point. Let's go ahead and divide it out to see what we get here. See if it reduces at all. Yeah, it reduces down to 143 over 3,215,975, and then as a decimal, 0.000044465. Or I like usually take the reciprocal of the answer. or say it's 1 in 22,489. Wow, that's pretty rare. Okay. That's it. Flange out.